Welcome back. Today we're going to talk about the greatest common factor, and we're going to introduce the concept of factoring and factor by grouping. To start, we're going to go back a little bit and we're going to take a look at prime factorization, something that we did earlier in the year. And a prime factorization is simply to rewrite a monomial as a product of its prime factors. So we'll start with some prime factorization of some whole numbers here, some easy ones. We'll rewrite 14 as a product of its primes. We won't use 1, but we will use 2 times 7. Those are both prime numbers, and there are no other factors, so 2 times 7 is the prime factorization of 14. 24 is a little bit more difficult. We'll use our factoring tree concept again. You have choices. We can use 2 times 12. We can use 6 times 4. I'm going to start with 8 times 3. Well, 3 is prime, but 8 is not. So we can continue to factor 8. And we know 8 is 2 times 4, or a better way to do 8 is 2 cubed. So a prime factorization of 24 is 2 cubed times 3. That's a product of our prime factors. 60, we can try 60. That's got a lot of choices as well. Probably the most common would be 6 times 10. You might do 12 times 5. 15 times 4 is another good choice. Let's go ahead and do 12 times 5. Because 5 is prime. Unfortunately, 12 is not. So we have to continue factoring 12 to 3 times 4. I'll just bring down the 5. 3 times 4 times 5. Well, 4 is 2 squared. So the prime factorization of 60 ends up to be 2 squared times 3 times 5. We can also find the greatest common factor. And the greatest common factor is the lowest degree or power of factors common to each term. So we could go back to our sample here and we could find the GCF, the greatest common factor, between 24 and 60. So we need to find the common factors. Well, 3 is a common factor. It shows up in both. And 2 is also a common factor. It shows up in both. 5, not a common factor. It doesn't show up in 24. So we're not going to worry about 5. And we want to find the lowest degree of the common factors. Well, 3 is, they both have 1, so we're going to use the 3. And then between 2 cubed and 2 squared, we'll use the 2 squared. So the GCF between 24 and 60 is 2 squared times 3, or 12. Our greatest common factor between those two numbers is 12. And we can also find the GCF with numbers that have monomials that have variables in them as well. The process stays the same. We find the GCF of 20. 20 would be 4 times 5, or I'll speed things up a little bit. We'll just call that 2 squared times 5. But we do count the variables. So x squared, y cubed. So that is the prime factorization of 20, x squared, y cubed. 6, well, that's an easy one. That's 3 times 2, and then we'll bring our x, y cubed down. So we want to find the lowest degree of the factors that are common to each term. Well, the common factors are 2, x, and y. So we're not going to worry about the 5 or the 3. We don't need to worry about those two, but we do have to concern ourselves with the common one. Now we want the lowest degree. So we're not going to use x squared, we're going to use x. The lowest degree of 2 is 2, and They're both y cubed, so that's a tie. Doesn't matter, we use them both. So the GCF between 20x squared y cubed and 6x y cubed is 2x y cubed. Now we've seen a little bit with finding the greatest common factor. Now we're going to look at factoring. Factoring is simply the reverse of multiplication. Probably the most common places you've seen it is in the reverse of the distributive property. The distributive property allows us to multiply in. So we would take the 2 and we'd multiply by 4x, and take the 2 and multiply by 7. So we have 4x times 2 plus 7 times 2, which is 8x plus 14. So if we wanted to factor 8x plus 14, we want to undo that multiplication. And we'd look in here and we'd say, wait a minute, we've got a common factor in 8x and 14, and that common factor is 2. 2 is our common factor, because 8x is 4x times 2, and 14 is 7 times 2, so we've got the common factor. So we can pull out that common factor. We can pull that factor out, and that leaves us with 2 pulled out, and then 4x minus 7, or what we have here, 2 times 4x. Well, I guess that should be plus 7. Can't read through there. So it's 2 times 4x plus 7. So we end up right back where we started again. Same numbers. One is distributed in, the other is factored out. So let's take a look at some samples. Let's start with something very similar to what we just did. 49x minus 35. You might recognize that 49 is 7 times 7 and 35 is 5 times 7. So our common factor in here is 7. So if I factor out the 7, I'm left with 7x minus 5. And you know you factored correctly if you distribute back in and you get your same answer, or your question back. So if I distribute the 7 back in, sure enough, I get 49x minus 35. So voila, I have factored correctly. Second sample problem, I have z cubed minus z squared. Well, both of these have common factor of z squared. So if I factor out a z squared out of both of those, well, z squared factored out of z cubed leaves us with a z. But if I factor out z squared out of z squared, it's not 0. I need my placeholder there of 1. So I'm left with z squared times z minus 1. And sure enough, z squared times z minus z times 1 is z cubed minus z squared. So I get the same thing back. This one's a little bit different. You can see each one of these has a factor of x in it, so I can factor out the x. 12, 10, and 2, they're all even, so I can factor out a 2. I'm also going to factor out the negative. So my common factor here is negative 2x. So if I take a negative 2x out of negative 12x cubed, I'm left with positive 6x squared. Take it out of negative 2x out of positive 10x squared, I get a negative 5x. And take out a negative 2x, again my placeholder, but this time it's going to be a positive 1. Not a negative 1, but a positive 1. Excuse me. And if you check your work, if you distribute back in, we should get our original problem. Now, I caution you, do not divide out. We're not dividing out. We don't want to lose our 2x or our negative 2x. So do not divide our factor out. Just leave it out there so when we can multiply back in, we get our same question right back. Here's some more samples, a little bit more complicated. You will see here we have 5 times x plus 3 plus y times x plus 3. And if you will, this is a lot like 5 times a plus y times a. Okay? A is like the x plus 3. And we could factor out that a. Well, we can do the same thing with x plus 3. If we pull out an x plus 3 out of both of those terms, we're left with x plus 3 times 5 plus y. And that's completely factored. So with our a's, we would have had a times 5 plus y. Well, what's the a? The a is the x plus 3. That's why we have x plus 3, a times 5 plus y. Here's another sample problem. We could factor out, they both have a z in there, so we will factor out a z. So this is very similar to what we just did. This is my a example. So we have 5 plus y times z. It's 5z plus yz. So I factored out that z. In this third sample problem, I have two terms. I've got a term 5x squared y cubed times 2m plus n. That is a term. And I have another term 2m plus n. Well, again, like we saw before, we can factor out the 2m plus n. So we have 2m plus n times, well, we've taken this whole thing out of here. We need a placeholder. Okay? Well, 1 will hold its place. So we're left with 5x squared y cubed minus 1. And I could distribute that back in, and I would get the same thing. This is going to come in real handy. This particular skill will come in handy when we do factoring by grouping. And here is factoring by grouping. Take a moment to write these into your notes. Factoring by grouping. We group the terms in two groups of two terms so that each group has a common factor. So that's what we're going to be seeking. Our goal here is to really, when we factor things out, that we've got a common factor. Sometimes that's hard to find. We'll factor out the common factor from each group. You should have a common binomial factor in each group. If you don't have a common binomial factor in each group, rearrange the original question and try again. So sometimes you will have to rearrange the terms to get things to work. And then you'll factor out that common binomial factor. I think the instructions may sound a little bit confusing, but once we do some examples, that will make a little bit more sense. So let's take a look at our first sample problem. We've got 4 terms here, so let's go ahead and just leave them the way they are. Okay, we will group those 4 terms, and let's see if we can factor something out. So out of the first pair, we can factor out an a. So we have a times x plus 4. So we factored out an a when we're left with an x plus 4 behind. So now our goal is, when we factor out of the second pair, we want the same thing left behind. We want this x plus 4 left behind. So 7x and 28 have a common factor of 7. I factor that out, I'm left with x plus 4. That is beautiful. I can factor out my common factor of x plus 4. This is just like sample problem back here with 5 times the x plus 3, where we factored out the x plus 3. Now we're going to factor out the x plus 4. So we pull out our x plus 4, and we're left with a plus 7 left behind, and we fully factored that. So let's try this other sample problem. See if this works. I have 28x cubed minus 7x squared. So a common factor in here is 7. looks like x squared. So I'll factor out 7x squared, and I'm left behind with 4x, and then minus 1. So now, with the 12x minus 3, I hope to be left with 4x minus 1. Let's see what happens. 12x minus 3 has a common factor of 3. So I'll factor out the 3, and I'm left with 4x minus my placeholder of 1. Excellent. I've left behind 4x minus 1, so I can factor that out. Get 4x minus 1 times 7x squared plus 3, and I have factored that. This one is a little bit more complicated. Let's see if this works the first time. We've got a minus here, so you plus or minus guys are going to love this because I am going to change this to plus a minus 4x. So that'll allow us to group 2xy plus 5y squared and a negative 4x minus 10y. So this is a plus sign in here. So my common factor, I see I can take out a y. Oh, that looks like all I can take out. So I'll take out y, and I'm left with 2x plus 5y. So my goal here is to take something out and have 2x plus 5y behind. Let's see if I can do that. It looks like I'm going to have to take out a negative sign because I've got a negative 10y. So if I take out a negative 2x, then I'm left with, and that's okay because I get this plus a minus, so we have a negative 2x. If I factor that out, I'm left with 2. Nope, I can't take my x out because there's no x in this term. So I can only take out a negative 2, and I'm left with 2x plus 5y. Now I have the same thing left behind. So my factors, I pull out that 2x plus 5y like I've been doing all video, and I'm left with y minus 2 left behind, and there are my factors. I think I'm going to leave this sample problem for you. I will let you do this one. I don't think that needs to be rearranged. You can bring that one to class and show me that you know how to do that. And I will do this one final sample problem. So 3x minus 4 plus x minus 12y. The way this is set up here, there are no common factors. So I'm going to use my commutative property. I'm going to rearrange. I haven't practiced this one. So I'm going to rewrite it as minus 12y minus 4. So I've rearranged this. Let's see. It looks like on the first pair and the second pair, I'm going to change that to minus. Of course, you plus or minus guys are going to love that. So I can call that plus or minus 12y. And let's see if I can get this to work. So 3xy plus x, I can take out an x. So I'm left with 3y plus 1. And here I can take out if I take out a negative 4, I'm left with 3y and a placeholder of 1. Just to make sure, if I distribute my negative 4 back in, I get a negative 12y, and then negative 4 times 1 is negative 4. So that's correct. I've factored out correctly. And beauty of beauties, I have the same thing left behind, 3y plus 1. So I can pull that out of each term. We get 3y plus 1 times our left behind, which is x minus 4, and we have successfully factored. So there's an introduction to factoring by grouping and using a prime factorization to do greatest common factor, and we will see you in class.